Hello everyone, my name is Athar Chauhan, and in this part of the presentation, I'll be explaining data smoothing for feedback and ratings. This is an important data pre-processing technique that helps us clean noisy feedback data and make the underlying patterns much clearer. Understanding the data smoothing. Data smoothing simply means reducing small random fluctuations in the data so that the overall trend becomes more visible. In the feedback analysis, student ratings may vary due to mood, inconsistency, or random behavior. Smoothing helps us cut through this noise and understand the real pattern. It's widely used in feedback rating normalization, detecting unusual patterns, time series trend analysis, improving data quality for models. In simple words, smoothing helps us see the actual story behind the data. Let's talk about the binning approach. One of the simplest and most powerful smoothing technique is binning. It works in four steps. Number one, divide data into bins. Group values into equal sized sets. Second, calculate the mean for each bin. Then replace all the values in the bin with the bin mean. Number four, analyze the smoother results. This reduces random fluctuations and makes the dataset more stable. For example, if bin depth is 3 and each bin holds exactly 3 values, making the trends easier to observe without losing the overall distribution. Now, example of binning. In this example from the slide, the original sorted ratings are grouped into bins of size 3. Then we calculate the mean of each bin and replace all the values inside that bin with that mean. This process transforms a noisy data set into a clearer one, making trends easier to analyze. So binning is great when you want simplicity and fast smoothing. Now detecting outlier detection. Before smoothing, we often need to detect outliers and values that are unusually high or low. Outliers can distort averages and trends, so identifying them is crucial. We use Z score, values beyond plus or minus 3 standard deviation are outliers. IQR method, anything below the lower bound or above the upper bound is flagged. Box plots, visual detection of outliers and pattern recognition, sudden drops or unusually high scores. Outliers could be mistakes or they could reveal real issues, like a student facing trouble in class, so we must interpret them carefully. Why outliers matter? Removing or understanding outliers help us prevent bias, improve reliability, detect genuine concerns, identify suspicious or random rating behavior. So handling outliers ensures that the final analysis is accurate and trustworthy. Now, the advanced smoothing techniques. Beyond binning, there are more advanced smoothing methods like moving averages data within a sliding window, exponential smoothing, which gives more weight to recent values, regression smoothing that fits a trend line through data, and LOESS or LOS uses local fitting for every noisy data. Each method has its own strength. Some are simple and fast, while others are more accurate but computationally heavy. Choosing the right technique. There is no single best smoothing technique. It depends on what you want to achieve, how large or noisy your dataset is, and whether you need simple trend smoothing or advanced modeling. How much computation power you have, you may need to test different parameters like bin size or window length to get the best results. Now, the key takeaways to summarize: data smoothing reduces noise and makes patterns clear. We make multiple methods like binning, outlier detection, moving average, exponential smoothing, regression, and LOS. Selecting the right method depends on your data and your goal. Smoothing improves clarity, accuracy, and decision making in feedback analytics. Thanks for listening. I hope you enjoyed the video. Thanks for watching.